What makes your phone smart or your computer powerful? The answer: the transistor. This tiny invention is the invisible engine behind every digital device you use. Packed by the billions into our gadgets, transistors are the building blocks of the modern world. Without them, there'd be no internet, laptops, or digital cameras. So what is a transistor? Think of it as an ultra-fast microscopic light switch for electricity. It flips on and off, creating a simple language: 1 for on, 0 for off. Every photo, song, or message is just a long string of these ones and zeros. Unlike a regular switch, a transistor is controlled by a tiny electrical signal, no moving parts. This lets a small current control a much larger one, a trick called amplification. In computers, their main job is to switch on and off at lightning speed, millions or billions of times per second. That's how your phone responds instantly, and your games run smoothly. Every tap or click triggers a microscopic dance of electricity inside your device, all thanks to the humble transistor. It's the tiny switch that runs our world. To understand transistors, we need to talk about what they're made of: semiconductors. Semiconductors, like silicon, can sometimes conduct electricity and sometimes block it. This makes them perfect for building electronic switches. Silicon, found in sand, is cheap and abundant. In its pure form, silicon doesn't conduct electricity well. Its electrons are locked in place. But here's the trick: we can change silicon's properties by adding tiny amounts of other elements, a process called doping. Doping lets us control how well silicon conducts electricity, tuning it for our needs. This ability to tune silicon is the foundation of the electronics industry. Every computer chip starts as a pure silicon crystal, sliced into wafers and precisely doped. Through chemistry and physics, we turn sand into the brains of supercomputers. The digital revolution is built on our mastery of silicon. It's engineering at the atomic scale. How does doping work? There are two main types: N-type and P-type silicon. N-type is made by adding elements like phosphorus, which have extra electrons. These free electrons carry a negative charge, making the silicon a better conductor. The more phosphorus, the more free electrons, and the more conductive the N-type silicon becomes. P-type is made by adding elements like boron, which have fewer electrons. This creates holes, gaps where electrons should be. These holes act like positive charges, moving through the crystal as electrons jump to fill them. So, P-type silicon is rich in positive charge carriers. With N-type and P-type silicon, we have materials with opposite electrical properties. By combining them, we can build the essential structure of a transistor. It's this clever use of chemistry that lets us control electricity with such precision. Two types of silicon, one powerful switch. That's the secret behind every digital device. Doping turns ordinary silicon into the heart of technology. It's the magic ingredient in every chip. Before transistors, electronics relied on vacuum tubes, big, fragile, and hot. Early computers like ENIAC filled entire rooms and used thousands of tubes, burning out constantly. Electronics needed something smaller, cooler, and more reliable. In 1947, 3 scientists at Bell Labs invented the first transistor, a tiny device that could amplify and switch electrical signals. It was a game changer: smaller, more efficient, and far more reliable than vacuum tubes. The inventors won the Nobel Prize, and the world of electronics was transformed. Transistors made devices smaller, cheaper, and dependable. This breakthrough launched the age of microelectronics. Suddenly, radios fit in your pocket and computers shrank from rooms to desktops. The transistor's invention paved the way for the digital age. One small switch, one giant leap for technology. The transistor kept evolving. The biggest leap? The MOSFET, invented in 1959. MOSFETs are easy to manufacture and can be made incredibly small. They're the backbone of every modern computer chip. Thanks to MOSFETs, engineers can pack billions of transistors onto a single chip. This led to Moore's Law chips double in power every 2 years. Today, your phone's processor holds billions of these tiny switches, each measured in nanometers. That's why your devices are so powerful and compact. The transistor is the unsung hero behind every text, video, and call. From room-sized computers to pocket-sized powerhouses, it changed our world forever. Science is cool, and the transistor proves it.